Hi, I'm Juniper Lovato. I'm a PhD student in complex systems and data science at the University of Vermont, and today I'll be presenting our paper, which is entitled More Data Types, More Problems, a temporal analysis of complexity, stability, and sensitivity in privacy policies. I'd like to start by thanking our lovely team, Phil, Parisa, and Peter. Collecting personally identifiable information on data subjects has become part of a multi-billion-dollar industry that profits from collecting, buying, and selling consumer information. The big problem is that there's little transparency in this industry, which makes it difficult to understand what types of data are being collected, how they're being used, and who they're being sold to, and to be able to understand the risk to individual data subjects. In our project, we take a mesoscale approach and analyze privacy policies over time, looking at the word, topic, and network levels in order to understand the stability, complexity, and sensitivity of privacy policies over time. We started our project by creating an original lexicon of personally identifiable information terms, and these are 287 words that are associated with PII, and we found the definitions and list of words using legislative text from 9 U.S. state laws that concerned consumer data privacy. The data that we used for this project is the Princeton-Leuven Longitudinal Corpus of Privacy Policies by Amos et al., and is a corpus of 1 million privacy policies from more than 100,000 websites, ranging from 1997 to 2019. In our mesoscale analysis, we began by looking at the word level and investigating turbulence of PII terms in privacy policies over time. So essentially, we took a frequency distribution of all of these PII terms and looked at them on a time series. And in these visualizations, which we colloquially call our PII smokestacks, we pulled out some words that fit certain conditions. So the first figure that you'll see here on the left is are words that fall rapidly, so they kind of go out of fashion. In the next panel over, you'll see words that rise frequently over a period of time. We look at words that emerge over a period of time, and then finally we look at words that remain fairly stable over time. And we see some interesting results. For example, words that fall more than 15% in a year. We see these are words that possibly in other areas could be replaced by words that are more specific. So we see words like coordinates dropping significantly in popularity. Whereas on the next panel, we see other geolocation words like geolocation, latitude, and longitude increasing and kind of taking its place. For words that are increasing and rising rapidly, we see a lot of words that are related to indirect tracking of personally identifiable information. So this is things like beacons, behavior, like internet browsing behavior, inferences, and geolocation. For our emergent words, we see mostly words that correspond to new technology or health-related terms that may not have been present in privacy policies before. And then for our stable words, what we mostly see are PII that would be collected on consumers to conduct regular business. So these are things like your address and passwords and things like that. We compare some of the spikes that we see in these time series just through a visual inspection to a timeline we put together of privacy legislation in the US and EU. And we do see some correlation between spikes of certain terms and these events. However, in future work, we would like to do a much more robust time series analysis to see how these correlate. And in the interest of time, I won't go over this in too much detail, but we also could use these smokestack visualizations as a way to query what words are represented in the privacy policies over time. And we did a couple of examples. So we pulled out words that were related to health in this left panel, and then words that were related to inference on this right panel. And we also look at the rise of words that are related to genetic information and location information. Interestingly, you can see that there's a quite steep rise in the word genetic and biometric over time. So let's move on to the topic level of our mesoscale analysis. And for this, we did topic modeling using a stochastic block model topic modeler. And we looked at topic prevalence over time. And what we see is that the topics actually remain relatively stable over time, with some trends that are related to spikes because of new technology or possibly privacy policies reacting to new legislation. And our time series analysis shows very similar results to what we saw at the word level, where indirect collection of PII is looking pretty popular. So we see that cookies really dominate the topic landscape throughout this entire time frame. And manually entered PII attributes like address and name and age show a high prevalence at the beginning, but are starting to dwindle over time. And this may be because these indirect methods of tracking are becoming more popular. And then behavioral data like preferences and movement are our third most popular topic overall, and we do see that they are slightly rising over time. So let's move on to the final level of our mesoscale analysis, which is the network level. And to investigate what words are used in the corpus, and later to see what data types are collected concurrently, we use a co-occurrence network analysis to represent the use of relevant terms within the same text. Co-occurrence networks utilize network analysis to represent the relationship between objects that co-occur in the same environment. And to create a word co-occurrence network, we essentially add an edge between words that appear in the same privacy policies. Edges start to with just one weight to begin with, and then if two terms from our PII lexicon appear together in additional documents, we increase the weight based on the number of documents that they co-occur. We measure sensitivity through network density of the co-occurrence network in context of modularity. So network density is defined as the proportion of the number of edges in a network compared to the number of potential edges between all pairs of nodes in the graph. Both the measure of network density and modularity will allow us to examine a fuller picture of the graph density qualified by modularity, which accounts for the network's size. So what we see is that density in the network rises over time, and that density and modularity show some spikes during critical times when new privacy legislation is introduced. And as we use these network density measures as a representation of sensitivity, we can say that co-occurrence of PII data type words does appear to be increasing. However, it's unclear whether this is a measure of increased concurrent PII data types being collected together, or perhaps just a signal of compliance with new legislation mandates, which ask for more precise PII data type disclosure. So it'll be interesting to see looking forward past 2019 when a lot of these new legislative mandates came onto the scene to see if these trends continue. Finally, we explore the complexity of privacy policies as represented by the compression factor of the corpus compared year by year. We see a steady decrease in complexity over time from 2000 to 2019. And essentially, the compression factor is just the bits of the minimum description length of the corpus divided by the bits of the non-compressed description. The smaller compression factors mean that the model can compress the corpus more. So the words inside of these models are more self-similar and easier to compress. This doesn't necessarily mean that this translates to human readability. It possibly could, but more work will need to be done to explore that comparison. In summary, we find that privacy legislation possibly correlates with changes in stability and turbulence of PII data types and privacy policies, that complexity of privacy policies decreases over time and becomes more regularized, and finally, that sensitivity rises over time and shows spikes that are correlated with events when new privacy legislation is introduced. Thank you again to my team, and thank you for listening. You can check out our preprint link here.